Hello, Prisma fans and future Prisma fans. My name is Martina Welander, and I am an education engineer at Prisma. I primarily deal with the documentation day-to-day, but today I am coming to you from not so sunny Denmark to talk about relations in Prisma. And for this presentation, we're going to go full circle, all the way from the database to the client API. And for each type of relation that we're going to explore, we're going to look at, first of all, how does that manifest in the database? What does the corresponding Prisma schema look like? And finally, what does the Prisma client API look like as a result? We are going to do all of this in 25 minutes, and we're going to try and keep it breezy, even though this can be quite a dense topic. So without further ado, welcome to Happy Table Friends, Relations in Prisma. And our journey starts in recipes.db, which is a SQLite database sitting on the ocean, smiling, with a bunch of tables in it. Most importantly, the recipes table. But it also has a bunch of friends, like authors and steps and ingredients and those sorts of things. And all of these tables have relationships between them. And I'm not going to assume any knowledge, but in a database context, the relationships between tables is represented by a database schema. And for reference, a database schema looks a little bit like this. Gorgeous. Prisma also has an idea of a schema, which is, funnily enough, called the Prisma schema. And it's a file that looks like that. Here is mine from this presentation. And it's written in a language called the Prisma schema language. And the Prisma schema represents exactly the same model as your database, but in this Prisma schema language. And there are two ways for you to create this schema. So you can either create it from the database. So if you're comfortable with SQL, you can create your database and then do something called introspection, where you literally point Prisma at your database and say, please give me a schema from this, and it will be automatically created. The second way that you can create a schema is to write it by hand if you are super hardcore. And then you can what's called migrate your schema from the schema file to the database. But whether you write it by hand or introspect, the schema is still the thing that binds your database and your Prisma client together. It represents your data model. And the reason we're bringing up the schema in the context of a relations presentation is that the Prisma schema includes information about the relations between all your models. So let's have a closer look at the first type of relation, which is a one-to-one relation. And a one-to-one relation might be something like one author has one profile. And actually one-to-one profiles or one-to-one relations, are quite rare. And you only really create them if you want to break up a big thing, like a person's personal details, into a bunch of smaller things. You might store the passport separately, driver's license separately, and that kind of thing. So in a database, this relationship is pretty simple. There is an author in a table, and they have a profile ID here, which links to the ID of a profile in a separate table. One author has one profile. Let's look at that in the Prisma schema. Here we have all the same fields. We have an author as a model. A model represents a table. We have the IDs, the profile ID, and wait for it though. Oh, actually, let me back up. I should mention that the profile ID is unique because one author can only have one profile. You don't want to share profiles. So far, it looks exactly like the database. We have the same fields, but here comes Prisma. And suddenly we have these additional fields, profile and author, which might look a little bit strange. And these are called relation fields. And they're going to feature heavily throughout this presentation because they are what define the relationship between models. Let's talk a little bit more about relation fields. So here they are for reference. Relation fields exist on each side of a relation. So you can see the author model has a profile field, and the profile field has a profile model has a author field, and at least one of those sides is going to have this relation attribute that describes a little bit more what's included in that relation. These fields, again, they don't exist in the database. They only exist on a Prisma level. and they are used to generate the Prisma client. So how you name these fields is quite important because it's going to show up in your API. And we're going to see relation fields come up again and again as we go through this presentation because they're part of every type of relation. So let's step through how this relationship field works, or relation field works in our current example, our one-to-one. So we have our profile field on the author model. The relation attribute references the profile ID, which is in the database. This is our relation scalar. And we're saying that this entire profile field via the profile ID should reference a key in the profile table. So if I go back, profile has a relation scalar, which references an ID on another model. So that's how a relationship is described in Prisma. If we jump to the Prisma client now, we can see how this all looks when it's generated into an API. So here we have an example where we are creating an author and at the same time creating a single profile. So the relationship has allowed us to link author and profile together automatically in our client API. And it works. It works in all sorts of queries. So that one was a create. This one is a find many. So find any author where the profile first name is Martina. And all of that comes from the fact that we were able to, in our schema, link author and profile. Jump ahead. Let's move on to a one-to-many relationship. A one-to-many relationship might be something like a author has many recipes. Other examples include one recipe has many steps, but it doesn't include one recipe has many ingredients. That's a many-to-many, and we'll cover that later. In the database, looks like this. We have recipes, tomato, sugar. Each one of them has, no, we don't. We have we have recipes, omelette or Thai green curry. Each one of them has an author ID represented by an integer, and that points to the ID of something in the author's table. So quite similar to the one-to-one, except that the author ID can be used multiple times in recipes. So one author can have as many recipes as they want. And there we go. I'm going to redo that bit. Nope, I'm not going to redo that bit. In the Prisma schema, this looks quite similar to the one-to-one relationship. So again, we have all of the fields that we had as part of in the database. We have the IDs of the author and recipe, and we have the foreign key, the author ID. And here come the relation fields. So we've got an author on the recipe and a bunch of recipes on the author. And the only difference between this and the one-to-one that we started with is that we have an array of recipes, or a list of recipes here rather than a single recipe. And then let's look at the Prisma client. So here we have a query to create a recipe where the author is also created at the same time. And we're also going to, as a bonus, create a profile. So we're jumping from recipe to author to profile here. And we can also find many recipes where the author has other recipes where the title contains prawns. Not really a query that you would normally run, but I'm just wanting to show you the kind of the flexibility that all these relations offer you. So we've gone from recipe to author to other recipes by that author based on that one relationship we've created, that one-to-many. The final relationship type that we're going to go into is the many-to-many. And this one is a little bit more complicated. So there are two types. Let's look at the first one, which is many recipes have many tags. And if we look at that in the database, it tends to look like this. And if you are unfamiliar with many-to-many relationships, we're going to talk a little bit more about this table right here that joins the two. This is called a join table. And it kind of stores information about how these two other tables should relate to one another. They don't really have a good relationship on their own. They need an intermediary to make sure that there's no drama. If we look at it with some data in it, you can see that we've got a couple of recipes here and a couple of tags. And if we look at the tag recipes join table, you can see that in the A column, which represents recipes, and I'll get back to that, we have 1 and 2, plain omelet and garlic prawns, and both of them are listed as B, or in B, as ID 24, which is easy. So the tags recipes table is storing information about recipes and tags together. It's a join table. And this, it has a strange name and it has weird columns. I mean, if you're familiar with join tables and databases, you kind of think that why are they called A and B? And that's because this is a magical join table, a Prisma specific, kind of boring, but magical join table. And to understand more, we can look at the Prisma schema. So when we generate or when we introspect that table and create a schema from it, this is what the schema looks like. We have tags on one side and recipes on the other side. So I can look at a recipe and get the tags, or look at a tag and get the recipes that it includes. But what about this little guy? So far, every single table in the database has become a model in the schema, but not this time. There is no tags recipes model. And that's because this is what's called an implicit many-to-many, which is a Prisma feature that introduces a little bit of magic. And here is the magic broken down and made less cool. So how do you make an implicit relation? How do you make implicit relation magic happen? Like, what is this weird little table with A and B columns? So the format of this table, the name must include an underscore. The column names must be A and B. And A and B points to, or A rather, points to the column that comes first alphabetically. So in our case, that's recipe, and then tag will be B. So it's a convention for creating a magic join table, which means that Prisma just knows how to relate recipe and tag. And that's what lets you have a schema that looks like this, rather than having a third table in here or a third model in here that links them together. So Prisma does some magic behind the scenes. And in the client API, it looks like this. So I am getting many recipes where the tags are, or any of the tags on these recipes are in this list. So anything with tag 1, 3, or 9 will be returned here. And that's possible because of that relationship. You can also go the other way because it's a many-to-many relationship. So I can look at a tag and find all the tags where the recipes contain the word tomato. So are there any breakfast tagged recipes that contain the word tomato, for example? But that's not all when it comes to many-to-many relationships. There is another type. So for example, many recipes have many ingredients. And excuse my tangent here, a tomato is just a tomato. But when you put a tomato in a recipe as an ingredient, there is an amount of tomato, which you need to store somewhere. And where are you going to store it? Now, if we look at the database, the traditional database way of doing this is to create a join table. Again, recipe ingredient you can see here, which has an amount. So recipes have ingredients, and when ingredients are inside a recipe, they have an amount. So it's a little bit more of an interesting but non-magical join table. So it's a little bit more familiar to those of you who do database stuff. And this in Prisma language is called an explicit many-to-many because you are defining exactly how the relationship should happen, and the Prisma schema is going to reflect that. Let's have a look at the Prisma schema. So we have recipe ingredient and that recipe ingredient middle table there. And we have all of the fields that are represented in the database already. And notice that recipe ingredient, because it's a many-to-many, it has an ID that's represented by both the ingredient and the recipe. It doesn't have an ID of its own. And it also has an amount. And for the purposes of this presentation, we are just making that a string. But in reality, you would probably model like a unit. So you can have deciliters or grams or whatever you need, feet, 10 feet of cucumber. And now it's time to add the Prisma relation fields. So somehow we have to relate recipe ingredient to ingredient and recipe, and it's going to get a little bit messy. Okay, here's the first one. So we're going from recipe ingredient to ingredient. You can see we have the same relation field here and a list on the ingredient side. And it becomes a little bit clearer when we use the API later. And then we need to relate recipe to recipe ingredient. Oh. So an example of how you would use this relationship, before I move on, is how often is tomato used as an ingredient? I can do that with the relationship I just created. I can also do something like, are there any foods that are never used as ingredients? The second part of the relationship is recipe. So here we have, each recipe has a list of recipe ingredients, and it's again represented by this relation field here. And it starts to get a little bit complicated with explicit many-to-many relationships. There's a lot of fields to keep track of, a lot of IDs. So what I like to do is model it and then try out the API and see if I like it. So let's do that. I mean, already, this to me, the word recipe ingredient isn't really working. I'm getting this sort of face. But let's have a look at the client and see what we end up with. So Prisma client. I've generated my client from the schema, and this is what we get. So if we try to read through this, we're saying, find me many recipes where the recipe ingredient contains, or where some of the recipe ingredient could contain an ingredient named tomato and the amount is less than 10. I don't really like how this reads. It's accurate. It's saying where any of the joins contain tomato, but the fact that we have recipe ingredient and then ingredient, for me, is not really ideal. I just don't like it. And there's nothing wrong with the relationship at all. It just means that the client API doesn't really sound human to me. And there's two ways that we can get around this. So I mentioned that we can name the relation fields whatever you like. So I might rename the relation fields in this example and get something like this. Find me many recipes where some of the ingredients details include the name tomato. So here I'm kind of stepping down from ingredients to ingredient details, and it reads a little bit more human. So that's one thing I can do to improve it. The second thing I could do is to completely change the model, going back to the database. So I might do something like this. I got recipes and ingredients, and between them, joining those two, I have a measure with a value and a unit. And if we jump straight to what the API would look like, it would look like something like this. So find me recipes where at least some of the ingredients include a measure with the unit grams. So I can kind of say that as a sentence without it sounding strange. So that's my second option. But however you do this, hang on. I've actually forgotten my next point. However you choose to model this relationship, you can either make the change in the database or in the Prisma schema. You have flexibility. What I really like about how you can model relations in Prisma is that you can make tiny tweaks to make sure that the API makes sense. And it's fast. So I can very quickly rename a model in Prisma and regenerate the API and start using it and try to make it more usable. So I have a lot of flexibility there. And those are your three main relationships. Let's take a step back and summarize. So we've gone through a one-to-one, a one-to-many, and a many-to-many. And there are a few more details which you can find in the documentations. There's a one-to-one self relation as well. So I, a category, might have a parent category. I'm relating to myself. But those are the main three that you're going to be dealing with. We've had a look at how relations are represented in the Prisma schema with relation fields. And we've looked at how the Prisma client is affected when you change the Prisma schema. I can't forget if it's too early. Blah, 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 blah. Yeah, I might do the in summary again. Let's back up and summarize what we looked at today. So in summary, we've looked at three main types of relations, and they match up to what you commonly see in a database. We've looked at the one-to-one. One author has one profile and vice versa. We've looked at the one-to-many. One recipe has many steps. And we've looked at two forms of many-to-many, an implicit one, where all you're doing is creating a relationship between two entities or two models without any extra information. And that was recipes and tags. And we've also looked at an explicit many-to-many, where the join itself has additional information. So that was our recipes and ingredients, with the amount being in the middle. And these relations match up to what you have in a regular database. This is not something that we've made up at Prisma. We haven't looked at one-to-one self-relations. So that's something like a category might have a parent category, for example. But you can find out more about that in the documentation. We've looked at how each of these relationships or relations manifest in the Prisma schema. Specifically, we've looked at the relation fields. And you're going to see those in all Prisma schemas. And I really recommend using the Visual Studio plugin because it will help you build these relations without having to necessarily know the syntax off by heart. It kind of feels like playing a really satisfying game of schema writing. And finally, we've looked at how the way that you organize your Prisma schema affects your Prisma client. And you can find out more information about relations and relation queries and everything to do with joining models together in the Prisma documentation. So thank you for coming on this journey with me into the recipe database and exploring all the relationships between the weird little tables. Thank you for your time.
Martina, thank you. Nice having you live. That was a really, really insightful talk.
Hi.
So, I mean, go on.
Oh, I just said hi.
I really love the illustrations. I mean, I'm a visual learner, so this is like my way of learning. You ready to take some questions?
I am.
Okay, so Peter Belbin asked the question: do implicit relationships work with composite primary keys?
That's a good question. We recently made a change to make implicit relations a little bit easier to use, and that does mean that they don't now support composite primary keys anymore.
Mm-hmm. Okay.
And the docs are going to be updated with that change imminently.
All right. Okay, and then I'd also like to call out Jess Martin, who's been really sparking some really interesting discussions, especially about one-to-one relations, and then being like, well, I mean, it seems like the discussion's conclusion is that they're perhaps suboptimal in some scenarios due to the way that rows are stored. Do you have any thoughts on that?
I mean, I can say that I found it really hard to create a good example. Mm-hmm. But the only thing that I could find was that it perhaps didn't perform as well if you had a massive record that you had to return. But I think that the discussion is probably more well-informed than I am. So I would recommend heading into that.
Yeah, check it out. It's a really long thread that I believe was started by Jess Martin, right? Yeah. Okay, so do the modeling with database or modeling with a schema. Okay. Need to understand.
What makes more sense, model with a database or model with a schema?
Yeah, do you want to try me on that?
I'm quite new to Prisma, and I only recently found out about Prisma Migrate, so the ability to write your schema and then migrate that into the database. I would say that we've marked Migrate still as experimental, so it might change a little bit more in future, but it's really up to you. Personally, I really enjoyed the writing the schema by hand, but you got to make sure that it meets your production needs first. Migrate, that is.
Yeah, I've also seen a really nice tool shared recently where it's like you can you can actually model it visually and then export the SQL from that. I'll try to find a link and I'll share it in the Slack channel.
Oh yeah, I've used that. I use dbdiagram.io. And
yeah,
like
that's
you
the
can
new
export,
one.
Yeah, you can export like Postgres or whatever you want, and I found that really useful. It has its own modeling language. So if you don't like writing SQL, I don't like writing SQL. I always have to Google it. Then you can use that.
Okay. If we have no more questions, let's see. Do we have more questions coming? Oh, okay. Zurin is asking, where can we get more table diagrams and relationship stories?
Oh, well, I'm going to take that as free reign to draw more during work time.
Okay. And any best practices or libraries for a hierarchical self-relations?
I not that well versed in that, to be honest. Maybe we should raise that in the chat.
Mm-hmm. Okay, so that was coming from Pascal. So thank you, Pascal, for the questions. And this is your last chance. So if you haven't already, feel free to chime in and ask your questions on the channel. And if not, we will continue. Yeah, okay. So Jess Martin just mentioned dbdiagram.io is a sweet tool for people who are just learning relational databases. A lot of our students at Lambda School use it. Cool. So thank you for the tip. And I believe that was the tool that we mentioned.
Can confirm. Really useful.
Yeah. Okay. So thank you so much for that, Martina. I really enjoyed your talk and hope to see you soon.
Thanks, everyone. Bye.